Now, since we are going to talk about triangles so much, we've got some different ways to classify triangles. So in your homework problems, when it asks you to classify a triangle, it's either going to ask you about the angles or the sides. So if we look at the angles of a triangle, if they're all acute, then we just call it an acute triangle. If we want to have one right angle, then we call it a right triangle. If we have one obtuse angle, so if we have one that's greater than 90, then we call it an obtuse triangle. If we're looking at the sides, if all the sides are equal, then we call it an equilateral triangle. If we have two of the sides equal, but not the third, then we call it an isosceles triangle. And if none of the sides are equal to each other, then we call it a scalene triangle. Another relationship we can look at between pairs of triangles is when we have similar triangles. Similar triangles mean that they have the same shape, but they're not necessarily the same size. The conditions for similar triangles, the first one is corresponding angles have to have the same measure. So if you have two triangles and you can see that the three angles match, then that means they're similar triangles. The other property about similar triangles is that corresponding sides are proportional. So if we find ratios of the corresponding sides, the ratios have to be equal. Let's look at an example of this. In this problem, they tell us that the two triangles are similar. That means that those two properties have to be true. So if we look at corresponding angles, they have to be equal. So this one's 45 degrees and this one's 45 degrees. That means since they tell us that this angle is 104 degrees, that means this angle also has to be 104 degrees. And notice in this one they've got it marked so we know which angles are corresponding. And this one would have to be corresponding angles because they're both obtuse. And finally, this angle is 31 degrees, which means that this angle has to be 31 degrees. In this one, we're supposed to classify the triangles. Since these both have an obtuse angle, that means they're obtuse. That's one way to classify them. The other way is looking at the sides. And if we look at this triangle, we know the three angles. And since the three angles are all different, that means the three sides all have different lengths. If we have three sides that are all different lengths, that makes it a scalene triangle. Let's look at this example. This one we've got side lengths. We know which sides correspond because they marked the angles for us. For this triangle we have all three of the sides. In this triangle we only have one side. So we can look at the ratio between the side that we know in this triangle and its corresponding side in this triangle. So we've got an 8 here and a 16 here. So the ratio of those two has to equal the ratio of the other unknown sides in the smaller triangle to the sides in the bigger triangle. For example, if we were trying to find the length of side EF, then our ratio would be EF over 32, since that's the corresponding side in that triangle. So the ratios have to be equal, and then we could take this equation and just solve it for EF. Now we could cross multiply here and solve this for EF, but an easier way to do this would be just to look at this ratio. This would reduce down to 1/2, which means our ratio of the sides is 1/2. And if we think about what would make this turn out to be 1/2, that would be if EF was 16. That way we'd have a 1/2 ratio for each one. And then we could also use that idea to find the length of this other side in our smaller triangle. Side DF, what we just found out is that this would have to be half as long as its corresponding side in the bigger triangle. Since this side is 24, then this would have to be 1/2 of 24, which would be 12. Here's one more example that involves similar triangles. And in this one, we'll have to draw the picture. So in this one, we've got a tree that casts a 38-foot shadow. At the same time, Joey, who is 63 inches tall, casts a 42-inch shadow. So we can draw two pictures, one to represent the tree and its shadow, and another one to represent Joey and his shadow. So here's Joey. We know he is 63 inches tall, and his shadow is 42 inches. So right here, what we end up with is a triangle, and we know two of the sides of the triangle. We also know in this triangle that this is a right angle because we have a vertical and a horizontal. Now for the picture with the tree, I'm not much of an artist, so I'm just going to draw the tree as a line. And this is what we're trying to find the height of. So this is what we don't know. I'm going to call that one X. We do know the length of the shadow. So we've got the shadow over here, and that's 38 feet. So here's our triangle here. Again, we know this would have to be a right triangle because we've got a vertical and a horizontal. The important thing in this problem is that these two situations are happening at the same time. That means that the sun is at the same angle. So that means that this angle that's creating the shadow is the same in both of these triangles. So this angle here is the same as this angle here. And since we've got a right angle here and a right angle here, that means these two angles are complementary. They add up to 90 degrees. And that means that this angle has to be equal to this angle. That gives us these two triangles where corresponding angles have equal measure. And that tells us that they are similar triangles. So if we can match up all the angles, then we know we have similar triangles. That means that corresponding sides are proportional. So if we want to find the length of this side, we want to look at the corresponding side in this picture, which would be the 63 inches. So we look at that ratio, x over 63. That has to be the same as the ratio of this side to its corresponding side in this triangle. So now we're just going to take this equation and solve it for x. This time I am going to cross multiply. So we would have x times 42 inches equals 63 inches times 38 feet. I'm leaving the units in there because I want to make sure that the units work out. If they don't work out, then I've probably done one of my ratios upside down. So I've got 42x inches over here, and I'm going to take the 63 times the 38. And then I'm just going to have the inches times the feet. And then I want to divide both sides by the 42, and I'm also going to divide by the inches. And this is where I can see that my units work out. Since I've got inches in both places, here they cancel out. And I'm going to end up with my unit of feet, which is what I wanted. So on this side I just have x, then I'm going to take my 2394 and divide it by 42, which gives me 57. So I end up with an answer of 57 feet. So my tree is 57 feet tall.